Hello all, welcome to a new video. In this video, uh, we will try to understand what is Spark and few of its concepts visually. So when I say visually, because it's Spark is a distributed compute, there are a lot of abstractions which are very hard to visualize what is going on. So in this video, we will try to uh, simplify or try to visualize how those things work behind the scenes. So let's get started. First thing first, what is Spark? So people who are watching this video, they might already be aware because you are here because you are a data engineer or you are trying to go into data engineering field or you are looking at something which allows you to process data at scale. So Apache Spark is nothing but a compute engine which runs on a distributed framework and processes data at large scale. When I say large scale, it means uh, the amount of data or the intermediate storage required for that data is such or it's so huge that it can't fit a single machine. For example, let's say you have a Mac, so it might have, let's say, 64 GB of RAM. Let's say it's a high-end MacBook. So you can't process anything which is, let's say, you can't process a data which is of 128 GB in terms of memory wise. So yeah, there Spark comes and helps. It's built on distributed compute. So it is a successor to the MapReduce framework, which used to subdivide the tasks in map and reduce phase, and they used to have intermediate desks for storing the intermediate data. So let's say you read something, you persist it, and then other process starts reading from that persisted storage, and then does some more transformation on it and writes it back to the disk. So that was the approach taken by MapReduce. Spark improved upon it by keeping it in memory because memory is faster. Like uh, reading from a disk is way slower than reading from a memory. So it's basically Spark tried to uh, bypass the limitation of reading it multiple times from disk and then doing the computations. It really helps, and that's why it gathered a lot of traction in the data community, and it now has become one of the default when it comes to uh, large scale compute processing. So yeah, let's so this is how Spark is. So basically, if we see, so Spark is where does Spark fit in the data stack? So when we talk about data stack, we have this storage layer where we store our files. Let's say it can be SDFS, S3, GCS, Azure Blob, or CFS. CFS is safe file system. So these are storage layers. These are where the files or the physical copy of the data gets stored. Then we have certain cluster managers. As I mentioned, because Spark is a distributed system, it's a distributed compute engine. So for a distributed compute engine to run, we need a distributed cluster. And that cluster, if we have a cluster, we require a cluster manager. For example, there are different types of cluster managers. For example, when we are running on local, so we have multiple cores, and the local system acts as a uh, con- coordinator for all those cores and how those cores are used by drivers and executors in Spark. Similarly, in the Hadoop world, we had Yarn. This is short for yet another resource negotiator. So basically, it says that from a cluster or from a pool of compute resources, how each job or how each process will get certain resources from that pool of resources is managed by Yarn, and that's what it is called, Yarn. Then we have Kubernetes, which also is a cluster manager, which works on container engine. Mesos and standalone is another uh, cluster manager that is available in Spark. Then on top of this, now comes the interesting part of Spark. So all these things, so these things are needed. The reason I have put this in the picture is because in future down the blocks when we go further, we will see how these integrate with Spark. So At the core is at the just as it is it's the Spark core engine, which actually does the everything. Like it's the process, it's the distributed compute engine. That's is the core layer. On top of it, we have multiple API. So Spark is we can process Spark using Python. We can use Spark in Java, Scala, and R. So these are APIs which are exposed by the core engine, and each engine uh, has certain way of executing things. For example, Java directly uses JVM, Scala uses the JVM, Python uses the GNI, uses an interface between the JVM because the Python work happens in the Python environment, then it talks to the JVM and sends the response to the core engine because Spark is written in Java slash Scala. So that's the different APIs that are there. And then on top of those, we have libraries. These libraries are add-on libraries, like add-on, not an add-on, but those are independent libraries. In a sense, for example, uh, to work with Spark, you might be okay with the dataframe API from Python. Well and good. You don't need if you need graph processing, then only you will need Spark GraphX library. If you are doing something on machine learning, then you will use the Spark MLlib. Similarly, if you are running in a streaming workload, then you will use Spark streaming libraries. But let's say all those use cases are not there. You simply want to use, let's say, you are writing a PySpark program. So in that case, you don't need these things. You can simply use the APIs, or you can use the Spark SQL. Spark SQL is the most versatile one because it exposes a universal layer on top of everything. So uh, SQL is very known in the data community. So if you are coming from a SQL background and you want to work with Spark, it is still allowed. You can just use the Spark SQL. Uh, and to be more specific, for example, Spark provides certain CLIs. For example, Spark has a Spark Submit API, which uses the jar approach. Then you have, which is by then you have simple Spark terminal, which can be for Scala. There is a PySpark CLI, which is for Python. Then we have Spark SQL CLI, which is for SQL. So when we say Spark SQL, you can directly write plain SQL, and then it will work out for you. So those are these are the components which are present in the uh, Spark components. So as I mentioned, there is a CLI, there is a cluster manager, there is a Spark core engine. Now the core engine itself, the execution engine, which is there, it follows an execution model which is called an some people call it master slave, some people call it driver executor, some people call it so different people have different assumptions, but basically what how things work in Spark is that you have a concept of Spark application, and that application has a driver. Driver is the central part. So central in a sense, it coordinates everything, and that driver has a driver orchestrates its work to the executors, which are running on the cluster, and that's why you see in between this cluster manager. So uh, when we say Spark Summit, or when we launch a Spark SQL code or something, so there is a driver program which keeps on listening to the input that you are providing. For example, let's say you said select star from some table. So that input is collected by the your CLI. It is sent over to the driver, and then driver decides, okay, what to do with this command. And for this command, where should I send my tasks? Where should the code go? So stuff, those coordinations are done by Spark driver. As there is a session and context as well, we will go through that in further down the line. So it's if you see here, this gives a basic approach, basic idea of what happens when we launch a Spark Submit command. So when we say Spark Submit, let's say we have this. These are as of now we don't have to worry about these things. You simply understand like this. These are the arguments that are passed to this application and certain configuration for the jobs to come up. So basically, when we are saying number of executors two, we are asking that, okay, there should be two workers working, and that each worker should have a 20 gigs of memory and four cores. Similarly, for driver, we are saying, okay, the driver should be of 20 gigs and should have eight cores. So that is something which is there. So what happens is when we do this Spark Summit, so this is a CLI command. So we have a Spark client running on our system where we said Spark Summit. And then what it does, it will first because we have said master Kubernetes, so it understands that K8 has this thing. If we have said master yarn, then it would have talked to an yarn resource manager. But here it is. That's why I've not written any yarn or Kubernetes. I'm simply saying cluster manager. As we see in the previous picture as well, we are talking about cluster manager. It's implementation agnostic. So CLI talks to, sorry, the client requests cluster manager that, okay, boss, I need to launch an application, so I need a driver. So see, the first thing is it talks to the cluster manager, asks that, okay, I need a driver. So the cluster manager then talks to the node manager, which is this node manager is a concept of the cluster manager understands how the nodes are managed. So where are those nodes which are free, which are not free, stuff like that. So cluster manager talks to a node manager and says, okay, boss, I there is a request has come for a driver. Do you have enough space? The node manager says, yes, I have. Then cluster managers launches a driver. This is but in nothing but a Spark application code, which sorry, Spark driver gets launched, and the application, whatever argument we have passed, let's say if we have given a jar, so that jar gets in downloaded in here, and then Spark starts to process that. Then Spark says, okay, if it saw that in the arguments user is asking for two executors, right? So again, driver talks to the cluster manager. This is the flow. So first, this is the numbers are according to the flow. So first it went to cluster manager went to the node manager launched the driver, and then driver asked for further information saying that, okay, I need I need two executors from you. So the cluster manager then goes to a different node. It can be the same node, it can be a different node. That depends. Just for clarity, I have written it in a different node. It can go to the same node as well. So the cluster manager will ask for a node manager that, okay, do you have enough space for two gigs to be launched with 20 gigs and 4 cores. So if this node had eight spare cores, because 4 into 2, 8 cores we need. So if it had eight spare cores, it would assign that an executor and memory as well. So 40 gigs of memory and 8 cores is available on this node. It says, yes, I can launch, and it launches that node. Node manager launches those executors. These executors then register, because the moment when cluster manager asks this thing, right, that, okay, you are going to launch, so it will also tell the when you launch, pass on this information to this executors that where is the driver running or who asked you for you. So the drivers register themselves with the driver. Sorry, executors register themselves with the driver, and then drivers, okay, so the executors are launched, they have connected to the driver, so they know, the driver knows that, okay, here are two executors that I can use to submit a task. So then from once the cluster manager notifies the driver that, okay, I have created two executors on this node, and the executors have registered to you, you can go and submit the tasks. So driver just simply says submits few tasks to this. Task can be anything, running a code, running a Python code, SQL code, or some transformation or anything that is happening. So that task gets assigned to the executors. Executors process them and then returns the results back to the driver. And the driver, whichever program was created, will keep on listening to the driver's log and see whether the job succeeded or failed. So this is how internally a job works in Spark. So as I mentioned, these are the summaries of that process, whatever we talked, that from where it goes and how it works. So Spark submits to the cluster manager asks node manager, and so on and so on. And then driver sends the task to the executors, and the executor returns the response to the driver. So that's basic flow of the application, or basic interaction of Spark with the cluster and executors, drivers, and stuff. Now that then comes a programming model. As you mentioned, that a driver launches an application, driver as an application. So what is this? Is that each Spark application is divided or broken into sub components, which these are layers in which Spark works. So, and a Spark application, first of all, it launches jobs. Jobs is nothing but an action. So, Spark has a concept of action and transformation. So, action is something which returns a result back to the client or back to the driver. Okay. And transformation is something which does not respond back to the uh, driver. For example, let's say if we say data from frame dot show. So is means we want to see the output of that particular data frame. Or let's say we say spark dot read and then we provide a path. So when we read that path, it's an act which is going outside of the purview of the Spark application. It is interacting with an external system. That's an action. Then when it is so, again, the distributed nature of this is that everything happens on the cluster, and then the response comes back to the application so that it can be seen by the client. So that becomes another action. Similarly, so there are for each action that we have in our Spark application, we will have multiple jobs. So each action creates one job. Now inside jobs, we will have multiple stages. Stages is nothing but uh, so this stage creation is done by Spark so that it can do certain things which are doable in memory without looking at data from other stages. So for example, let's say if we have a data frame and we want to run a transformation on top of it, let's say we want to add one to each row, one certain column of each row. For example, we want to increment, let's say, or we want to give, let's say there is a data set which says that okay, every employee is getting a bonus. So that's one increment that is happening. So that is a transformation that let's say if we have divided the job is working on, let's say, five different partitions or five different segments of data. So each data is independent because this addition is independent. It doesn't need to know, let's say my row, if I am incrementing something, let's say row one is incrementing something, it does not depend on row two, right? It's totally independent of each other. So those are independent transformations happening, and those does not need to know each other. So that becomes one stage. Let's say if we want to combine results from those and let's say uh, build something which is dependent on the partitions that are there, or the segments of data that we are talking about. So those transformations requires a shuffle. Basically, shuffle is moving data from one node to another node, or one executor to another executor on a different node. So that kind of shuffle that happens is something which creates a boundary. So Spark does that so that it creates this boundary for each to be more reliant and fault tolerant. So something happened in that particular stage, it can roll back. But if let's say if we do everything in one stage, and the data exchange is also happening in that, so it will be difficult for Spark to manage that. So that's why Spark creates a boundary. So those smaller tasks which does not have any dependency are grouped into are part of one stage. The moment there is any shuffle requirement, then there is a boundary created, and then the new stage gets started. So as here it's mentions as well that stages for each shuffle operation are mentioned in here. And then again each stage has multiple tasks. For example, stage 0 has task 0, and in Spark every the task gets incremental IDs. So if you see in your logs as well, it will have executor 1, sorry, task 1 2, and it keeps on increasing. So let's say if task 0 got finished, it will start, let's say some other task comes up that will have a higher number. So C 1 2 3 4 5 6. So these are the layers in which Spark application works. So we have application, then we have jobs, we have stages, we have stage boundaries. For a stage boundary separated by exchange. Exchange is nothing but a shuffle that is happening for data to be processed from one data to be combined from different partitions or different partitions that are there. So that exchange happens, and then the individual task gets executed. So this is the programming model of Spark. So and in other terms, how it works is like this. Uh, we saw in earlier, so driver program, it's text application. It creates different stages. As I said, the DAG scheduler divides the job into multiple stages. Then it assigns tasks. So task assignment happens, and then there is a concept called task scheduler that assigns each task. The task is executed. So the tasks are executed on the executors in parallel. So and then when it is complete, the results are persisted or sent to the driver. So this is the normal flow. And how the job start, then job divides in stages, stage divided into tasks, Spark driver schedules the tasks, executor registers the task, executes the task, completes, and then job gets completed. So this is another. And shuffle, so job starts, task executed in parallel, and then it does a shuffle. It repartitions the data, then again the repartition the data is executed in parallel, and then job is completed. For example, why this shuffle and repartitioning is here, I will tell. Let's say we are doing a group by operation. So group by, let's say we are saying group by department. So the files might not have one single department's data, right? One file can have one department's data can be landing on, let's say, 4 different files, because it was in that way, it was loaded in that way that one single file does not contain all the departments all the data for a single department. It can be divided. So if we are doing a group by, so let's say we have 4 different partitions in which a certain department's data was present. So that data needs to go to one task, so that while we are doing, let's say on the group by we are doing an addition. So one particular executor will be able to do all the execution, all the summation, if that it knows that okay, these are the keys on which this is grouped by, and all those keys are present in there itself. So that's why this repartitioning is happening. Okay. Uh, so these are nothing but again, these are some questions like how many jobs gets created, and it's all something which we can understand by looking at how many actions are called. Is there any hidden action, and if that will also create a job, and so on and so forth. We'll go deeper in other videos how we identify those things. There is a this is different. So Spark has 2 APIs. One is RDD API, and there is a data frame API. So RDD APIs are very core at the core. They are very at the what you call closer to the machine, and generally it is recommended not to use RDDs. Better engines are dataframe and SQL, because if you see in between there is a Spark SQL engine which has a lot of optimizations that are inbuilt, which does is not available to the RDD APIs. So if you are writing something in the RDD APIs, those optimizations will not come into picture. But if we are using Spark SQL or dataframe API, those that goes through the SQL engine, and hence they will have more performant nature, or more performance, uh, and more throughput, and better results, better execution runtimes. So this is another. Now, I was saying about right partitioning and how data is visualized or data is stored in. So let's say a data frame is there. Let's say this whole bigger box of dotted lines in brownish color is, let's say this is a data frame. So how this data frame will look like in your cluster. So you have, let's say, 3 nodes. Uh, uh, so each node have, let's say, certain cores. So each cores represent one particular partition or one particular segment of data. So executor, then inside executors we have partitions. I mean, execute not an executor, worker you can say. So when we say Spark loads the data, it creates a data frame. Data frame is distributed across the cluster, across nodes, and it is divided into partitions, and each partition can live somewhere else. Now in this case only, if you see, let's say if we have a data frame which is of, let's say, 100 GB and our executors are, let's say, of 50 GB, sorry, not 50, 25 GB. So we will need 4 executors. 4 different executors might be running on 4 different nodes. So logically, it is represented like one single unit, but it is not present on one node. It is present across, it is distributed across the cluster, and each of the node plus executor combination plus executor core combination holds a partition of that particular data. So this partition is present in here, and let's say this partition had, let's say, department 1, department 2, department 3. This had department 1, 2, 3, department 1, 2, 3. So if someone wants to group by, so this partition should also come to the other executor, and similar way it will have to be shuffled. So from here the data should go here for department 1, and department 2 it should go here. So that way this shuffle comes into picture. Why we are, let's say, when we say df dot group by, why shuffle comes into picture. And these cores are for parallel processing. Let's say executor core is there, so each core processes one particular partition. So if, let's say, this executor which is there, let's say this is an executor, it has, let's say, 3 cores, so it can in parallel can process 3 partitions. Once those 3 partitions are done, it will pick up another 3 and then execute. And then this is the memory view. So if you see bottom, so this is the executor memory, these are executor cores. Memory stores the partitions, and processing of on those partitions is done by executor cores, right? So this is how a data frame is represented in Spark. So this is very interesting to know. And there is one thing called, as I mentioned, there was a concept called uh, Spark session and context. So earlier it was like this. Nowadays it's one simple thing. You only have Spark session, everything else is abstracted. You can still use context, but not recommended. Only you use context when it is really necessary. Otherwise, it's good to you create a session and then start working on that. But if you need Hive access, you will need Hive context. If you need, which is implemented again by SQL context, and then there is a streaming context for streaming workloads. So yes, this is also there, but we will discuss this in more in some other videos, why we need sessions, context, and stuff like that. So this video was majorly to make you feel or make you visualize how when we talk about a Spark cluster or Spark program, what it's actually, how, what is the mental model, how it will look like. This is another example where we have for example, let's say you might have seen you are running an EMR cluster, or let's say you are running on Kubernetes, Spark on Kubernetes, or you are running a Spark cluster. So cluster manager sits is somewhere else, and not somewhere else. It is a separate what do you call, like in logically it's a separate thing. Drivers will have so application has a driver and an executor. But where is driver running? It will run on one of the nodes. Where is executor will run? One of the nodes. But there can be multiple applications, right? It's not that only you will submit one and then keep on waiting for that. So there can be parallel submissions of jobs as well. So there will be two for each app. There will be a different driver, different set of execution, and they are logically grouped together, and those can run in parallel. And those are not, they will not talk to each other. They will talk to themselves. And if you there are certain cases where you can use one job's output in other jobs, but they will not directly contact. They will generally contact using a third layer, like a persistence layer, and then only they will be able to talk to each other. Or let's say there will be an event bus. So this application sends an event to a Kafka topic, which is consumed by this particular application. So that can be one scenario. But in general, these are isolated. So yes, this was it. Uh, we'll come back with another video which will talk about another aspect of Spark. Thanks.